The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI Conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
All right, our next speaker is Tony Thompson. Tony's the marketing manager for Vulcan Materials Company, Northern Concrete Division. Tony's worked in the ready-mix and precast industry in Northern Virginia for more than 20 years. Tony's held positions in technical service and ready-mix sales. And as a graduate of James Madison University, he holds various ACI technical certifications as well as NRMCA concrete technologist, certified concrete sales professional, and certified pervious technician. Tony's been active in the promotion of concrete with the Virginia Ready-Mix Concrete Association, Concrete Advisory Council, and is the current president of the ACI National Capital Chapter. Tony.
Well, a lot of what I'm going to say has already been said, but hopefully this all builds on some of the previous presentations. This is a real-life project situation. So at the National Zoo in Washington, D.C., I don't think any of the information here is going to be a revelation, but several of the same practices are going to come through as you saw in the other presentations. And I'll apologize ahead of time. This was intended to be very entertaining, but unfortunately I've lost some of my audio, and I don't know whether it will come out. And some of the audio that's in here might be overwhelmingly loud, so I'll click through it really quickly if it's really. Again, this is the project was the Smithsonian National Zoo. The Smithsonian took over the zoo in 1890. It was authorized by an act of Congress in 1889. The zoo that we talk about in D.C. is the National Zoo. It's 163 acres in northwest D.C., borders on Rock Creek Parkway. It's a really nice setting. One of the unique features of the zoo is that one of the three gentlemen who were involved in designing the zoo was Frederick Law Olmsted. That's where all of the original landscape plan for the zoo originated. The project, the $30 million project awarded in 2006 and completed in 2011, William V. Walsh Construction Company, a local contractor, was a general contractor. They also self-performed a portion of the architectural and all the rest of the concrete walls that were involved in the job. Because they work in Washington, D.C., we've got a lot of architectural projects. We work on a lot of monuments and memorials and things. So most of the general contractors have experience in this sort of thing. And William V. Walsh is one of the ones that have done this. They also acted as the general contractor on the FDR Memorial that was built there a few years ago. The elephant habitat was it was just an old barn. Because the zoo was so old, it was originally just a typical zoo with a lot of animal containment, just big buildings with, I guess originally bars, but not those bars to keep the animals out. They've changed a lot of things back to more natural habitats, and that's what they wanted to do with this project. It contains a new elephant walking trail so that the elephants can actually pass through some portions of the zoo. There's an overpass with a bridge that allows you to look down, and you can get closer to the elephants with this new project. It passes all through this different outdoor habitat. And I'll show you some video that hopefully it'll look okay. And you'll be able to see some of the areas that we've done to make it look like the real habitat. Again, Walsh self-performed structural concrete, including the integrally colored architectural walls. The mix on the job was a 0.40 water cement ratio, 5,000 psi concrete, with number 8 coarse aggregate. It contained 676 pounds of cementitious material, and by the time we were done with the job, it was 50% slag and 50% Portland cement. And one of the things that we mentioned earlier, one of the ways that we were able to control the temperatures during the summertime and set times and slump loss and things like that was to increase the slag content. The original specification called for 25% slag, and it was changed and approved at 50%. And of course that did affect the color, and samples had to be made of those new slag contents to make sure that they were acceptable. Now, in this particular instance, we actually made samples with the new slag content, and the owner was happy with the new one, so we actually didn't change the color dosage, which made it a little bit easier on our work. Now, I work for Vulcan Materials. We were the concrete supplier on this. We also had, this is one of the first projects that we used hydration stabilizer on. Now, I'll show you a little further in here down the slide. It was critical because of our location and the time it was going to take to place it. Halston, Wisconsin was the concrete subcontractor for the shotcrete portion of it. They did all of the architectural boulders and recreated habitat part of this. The specification that we worked from for this was unfortunately one, they're kind of particular, they had their own ideas about what they would like. So the spec was based upon their mix design, which was 940 pounds of cementitious material, 75% Portland, and they adhered to the 25% slag content. We were able to use a retarding water reducer in this. I will say this, the majority on this of the shotcreted portion of this was done during cooler weather. But there were some portions of it that were done in hot weather. That would have been really difficult if we had to do that during the summertime. Total distance to the job from our place is about 15 miles. We've batched this from a place in Springfield, Virginia. And we're fortunate at that facility that we have our central concrete lab is the next stop past the wash rack at that place. So we're able to keep a close eye on what comes out of that plant. This plant also has the ability to handle multiple materials and also has a liquid color dispensing system. That was one of the reasons that we used this particular facility for this job. Again, total time midday, 37 minutes. Total time to the job during rush hour, and rush hour in DC has gotten to the point now where it practically goes all day. But starts early in the morning, say 6:30, and may not be done until 9:30 or 10 o'clock. Those early morning deliveries would have been really problematic with that 50 to 70 minutes of travel time. We also used hydrotent colors in our liquid dispensing system. We used sandstone, adobe, and mesa puff. All of the walls were done with adobe on cast in place intervals. The other three were used in combination for the shotcrete. ACI, from 305, the definition of hot weather, it's not really like cold weather where there's a specific number of days and temperatures and things. It's more like one of the things, you know it when you see it.
I know it when I see it.
Thank Justice Potter for that comment. Anyway, this is a little bit of shaky video. But let's just see. This is the upper end of the habitat. This is the bridge that crosses over. Well, this is really bizarre in real life and on the big screen. It doesn't look nearly like this one. Like this on my laptop. Anyway, okay, those are all shotcreted walls on the side. This is a recreated cast in place and shotcreted pool and walls for the pool. There's actually down at the other end, there's another area where you can actually come and see the elephants. And that's actually the enclosure in the house and the yard where the elephants hang out most of the time. I've got a control area where there are cast in place interval walls around the building. Okay, back to the thing about hot weather. Hot weather is a combination of the following conditions. It tend to impair the quality of fresh and mixed concrete. So the things that we're looking at that we're defining hot weather with are high ambient temperature, high concrete temperature, low relative humidity, and high wind speed. It could just be one of those. So we could run into what we would think of as hot weather conditions a lot of different times of the year. Now in Washington, D.C., it gets pretty hot in the middle of the summer. It gets very hot in the middle of summer, as is the whole, East Coast. But, it doesn't stay hot for long periods of time. So while we're prepared for hot weather, it's not like people who work in, southern Florida or in Texas, Puerto Rico. We're able to accommodate it, but it's just not really practical for us to be prepared for hot weather at all times. doesn't have to be hot to be hot. And it doesn't have to be decorative to be decorative. And what I mean by that is that in this particular project, it's not like traditional decorative concrete, where it's noticeable or bright or distinct. It's natural decorative, where we're trying to blend in with the environment and create illusion. Normally muted colors, which is fortunate because iron oxide pigments use colors. But ultimately, decorative concrete is defined by the expectation of the owner, like we saw in the previous slide. In the previous presentation, the airport was normal colored concrete, but they had an expectation of the form, finish, and the color that they would have as a result. On this job, much of what was done to make this work well, we're following a lot of the principles that we talked about earlier in the earlier presentation. We want to communicate reality, and that's all part of communication. Look at it realistically. What's really going to happen? Don't sit back and assume that everyone's going to be able to meet all the specification requirements precisely, that all these accurate, absolute conditions are going to be perfect and work out well. I mean, everyone needs to talk about this stuff ahead of time. We need to know about the travel time. Don't just ask, we could have said to this customer, 37 minutes of travel time, but that's not accurate. It could be 37 minutes, it could be an hour and 20 minutes on occasion, but they need to know that. They also need to be realistic about traffic. Coming from different directions, different alternate routes that things are available. We need to think about these things ahead of time. And we also have to anticipate slump loss. We know that slump loss is going to be a concern. Why wait, again, just as we said before, why wait until after the fact to address it? We know it's going to happen. Let's look at what needs to be done and what can be, what allowances can be made to this in order to overcome that problem. And we also need to let our folks know, like I say, in Washington, D.C., we may run into some conditions where if they absolutely insist on meeting a specification or even an allowed specification, something beyond what was originally intended, we need to know there may be situations where we can't add enough ice, we can't have enough chilled water to meet that concrete temperature, and there may be requirements that we can't do a pour, that we're going to try to adhere to this. And also be realistic about placement time. When I do a project in my house, my wife will say, well, how long is that going to take? And I'll say, well, it should take 30 minutes, but everything takes twice as long and is twice as difficult as you think it's going to. Realize, I've placed concrete at my house before. It takes a lot longer than you think it's going to. Time to get the truck in, time to test it, and goes and looks for all their stuff. Placement times are a lot longer than what people think they're going to be. We need to communicate and be realistic about how long it's going to take. Now, some of that can be overcome with some other decisions. We'll talk about that too. Maintaining calm is one of the things. Again, communication with everyone. Specifications need to be well communicated and addressed, and then the allowances that need to be made, should be made. Look at actual job site conditions and actual temperatures. And realize that the parameters may actually be tighter because of contractors' restraints. For instance, the shotcrete spec may allow for a slump up to 8 inches. And our mix could well perform in that range. But the contractor may only want to pour shotcrete at 4 inches, 3 inches. So the parameters may be tighter than we're anticipating. And on our end, as a concrete producer, we need to realize that. We can't sit back and assume that there won't be any problems with this because it'll be such a workable mix. The contractor may not be able to use it the way that we think that he may be able to. And on this, contractor cooperation is important. Again, they have to be ready. Forming has to be ready, has to be ready to clean.
I am ready!
Should have handled all the provisions for hot weather concrete work, cooling form work, and all that. All the tools need to be there to reduce that placement time. They need to have all the personnel ready. And on architectural concrete, consistency is, as we've heard earlier, is probably one of the most important items. We can change some things, we can do things differently, we can have temperature higher, we can have water content higher, but as long as all of it's done at the same slump, the same water cement ratio, temperature and placement, consistency will end up with consistent color. And sometimes even personnel involved can affect that. Different people work with vibrators, different people, keep an eye on the concrete. If they try to keep their personnel consistent, it pays off. They Also, whatever method of conveyance that they've got, if there's a way to keep it the same, obviously concrete that's dumped from a chute is not the same as concrete that's pumped into the form. So if there's a way to make sure that those methods of conveyance are available and that they're ready to go when they get there. Again, advanced scheduling, anticipate the weather, anticipate traffic, and on our end, we're going to make sure that we have ice available. Again, we don't have it at all times, but once we get a certain point in the summertime, we're going to have ice. We use ice in a combination with chilled water in order to maintain the temperatures on this project. And any other conditions that would prevent us from being able to make that delivery or have to cancel that pour. And in this project, there were some instances where we had to cancel things like that. Now, the contractor on this job, in order to make sure that we were able to make placements, we have to lose the benefit of being able to pour maybe at 6 or 7 o'clock in the morning because of travel time. So we had to either look at travel time or temperature. So we opted to go with, and this was an agreement beforehand, to go with a later shipment time. All the placements for the integral colored walls were done at 10 o'clock in the morning. The load sizes, although they could use more concrete, loads and placements were reduced in size. Load sizes were 6 cubic yards, so that once they arrived, we didn't have dramatic changes from the front to the back of the load. They could actually place all that in a reasonable period of time to be consistent. On the quality assurance and control end, again, we're lucky that we've got our laboratory there all the time, but we want to make sure that we've prepared ahead of time at the plant. The plant needs to make sure that one thing, empty the bins. The bins keep the coarse aggregate materials down on the ground overnight so that we don't develop high temperatures, but being stored up in the bins. So, and we take advantage of the evaporative cooling from keeping the stockpile dry. That's one of the things that the plant can do ahead of time. Technical services, and again, our lab is right there on site. We review the mixes during hot weather, or all the time, but particularly in hot weather and architectural concrete, review these mixes continuously. When we're using high-range water reducers, air and training agents, hydration stabilizers, and other retarders and water reducers, we adjust the dosages on those as we need to as temperatures change. So we review those mixes regularly and make those changes and adjustments frequently in order to maintain consistency. And in this instance, we have a technician who's on this job, and actually on all projects at this plant, who's permanently stationed at the wash rack of the plant and checked every load that came out to make sure that we were, in a correct slump range, temperature and air content. Obviously, when we're in DC, we have to be concerned about the freeze fall, so air content is an issue. A couple photos of the job. Looks a little bit better than the video though, but this is during the summertime. It's from the lower yard. The video was taken up on top of the bridge. This gives you a little idea of what the walls in the lower yard. It's very nice, grassy. And from where this photo was taken is actually a reviewing area where people can actually get right up close next to the elephant. This is a picture from the back side of the building, and those are some of the integrally colored cast-in-place walls that were done, as well as the wall of the building. So, relatively short, relatively simple. Again, I hope it built on what everyone else had said, but I think the important parts to take away with architectural concrete in hot weather, or architectural concrete in general, are that communication is absolutely imperative. Everyone needs to stay calm, not get too overly excited about it. There needs to be cooperation from everyone involved. You need to understand, how the other people are going to react to this. And we also need to be consistent. Consistency, as you've heard, is probably one of the most important things with architectural concrete. If we can maintain that consistency, we can end up with a good architectural product at the end, even in hot weather. So. Sure.
During the hot weather, how much re-tempering did you do with water at the site versus hiring?
Well, again, we don't want to really think of it as retempering. On this particular mix, it's using it's had a polycarboxylate high range added at the plant. And we were typically batching at a lower slump than they wanted to pour. So we were holding a predetermined amount of water from each load. That was communicated on each batch ticket, so they knew what they could batch, what they could add and make an adjustment on the site, again, to be consistent with it. There wasn't a lot after that. Because they'd reduced the load sizes, if they got there and they could usually make one addition of water, a small amount, normally between 5 and 10 gallons, get it to where they wanted, that would be enough to get that slump put in place 6 yards and not have to do anything else to it.
Those walls are great. I'm curious, architectural color, what do they look like 6 months later? This seems like an environment that would be dirty.
What? But yeah, you know, that I took. This was a zoo photo, and I'm not sure when they took that. I would have assumed. I mean, it's obviously summertime, but it must have been last summer. I was up there take the video a couple of months ago. It looks to be in pretty good shape. I don't know, maybe elephants don't rub up against the wall like other stuff does. I've never had an elephant. I mean, my dog does, but I've never had an elephant at my house, so I'm not really sure. It all looks in pretty good shape still when I saw it. Yeah.
The rock walls, those are shotcrete?
Those were shotcrete.
Okay. 75% cement, 25% white.
Right. Slag, right.
Any reports of plastic shrinkage issues or products? I believe that's sculpted kind of product.
It is. No, and I don't know that with them being used for what they're used for to look like rocks. I mean, there's probably some imperfections and things that fortunately don't become an issue. It's one of the advantages to that sort of architectural concrete. Again, a lot of the shotcrete was done during cooler weather. There were portions of it that were done in the spring and the fall when we did have some. We certainly had some higher temperatures and we had some high winds. Some of the other conditions that lead to that we would call hot weather concreting conditions. But fortunately, a lot of that really high cement factor, the mix was done in cooler weather. Yep.
How did the slag affect the color, the initial color?
Well,
did you have some bluing and it changed tint over time? How did that affect it?
I don't know that I saw any of those immediately after they were stripped, but I don't recall there being any problem with that. Normally once that's, we use slag at most of our facilities. We also use some ash, but most of the product that we ship is slag and have used it for a long time. For regular walls, both sides of them, out of the ground with no water, water source, normally if there is anything, it goes away pretty rapidly. But of course the slag does affect the color, changes the colors to more pastel, a lot like the addition of water will. So that was taken into consideration ahead of time, but when the new samples were made with 50% slag, the owner was happy with the color. Yeah, again, it's a little whiter, than it would have been. They were pleased with the way it looked. Yes, sir.
I have a question about the reduction of the load. When you went down to 6 yards, was that because of placement restrictions, and if so, what they are, or was it a standard procedure for architecture?
Well, we recommend that for architectural concrete all the time. Unfortunately, a lot of times, as I mentioned, there needs to be cooperation. A lot of times, contractors don't really feel like cooperating. They'd rather treat it like regular concrete. We were fortunate in this instance that the general contractor self-performed, and they've done a lot of work, again, on monuments and memorials in Washington, D.C., so they knew what they needed to do. So it was really for placement. It was for placement time, and it was an agreement between both parties that load size need to be reduced. If they hadn't, we would have run into slump loss throughout the load, and I'm sure we would have had difficulty. There would have been need to, either retemper or add superplasticizing to regain slump. So I think it worked out well that they used the smaller sizes and smaller pores.
Question? All right.
Okay, thank you.